Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is propagation delay from Unit 2 combinational logic circuits. On completion, the students will be able to describe the important parameters for delay estimation and also be able to explain the implementation of RC delay model. Delay estimation. Delay estimation includes the following parameters such as propagation delay time, contamination delay time, rise time, fall time, and the delay estimation response curve. Propagation delay time. This is defined as the maximum time from the input crossing 50% to the output crossing 50%. And contamination delay time is defined as the minimum time from the input crossing 50% to the output crossing 50%. Rise time is defined as the time for a waveform to rise from 20% to 80% of its steady state value. Similarly, fall time is defined as the time for a waveform to fall from 80% to 20% of its steady state value. And we can calculate the edge rate from obtaining the average of both rise time and fall time. Delay estimation response curve. When an input changes, the output will retain its old value for at least till the contamination delay duration and take on a new value in at most the propagation delay duration. And the rise and fall times are also called as slopes or edge rates. Propagation and contamination delay times are also called as max time and min time respectively. We can observe the above in the following delay estimation response curve of the CMOS inverter. So here we have the rise time, fall time as well as the propagation delay and contamination delay time. The gate that charges or discharges a node is called as the driver gate, and the gates and wires that are getting driven are called the load. Propagation delay is generally termed as a delay. Arrival times and propagation delays are defined separately for the rising and falling transitions. The delay of a gate may be different from different inputs. Earlier arrival times can also be computed based on the contamination delays. Expression for delay for rising output is given as TPLH is equal to 0.69 Rp into Cl, where Rp is effective resistance of a PMOS transistor and Cl is the load capacitance of the CMOS inverter. Similarly, expression of delay for falling output is given as TPHL is equal to 0.69 Rn into Cl, where Rn is the effective resistance of the NMOS transistor and Cl is the load capacitance. And the propagation delay of the CMOS inverter is the average of the above two values. RC delay model. RC delay model approximates the nonlinear transistor IV and CV characteristics with an average resistance and capacitance over the switching range of the gate. Effective resistance. The RC delay model treats a transistor as a switch which is placed in series with a resistor. The effective resistance is the ratio of the drain source voltage to the drain source current. A unit NMOS transistor is defined to have an effective resistance value R, and the NMOS transistor of K times unit width will be having the resistance being scaled as R by K because it delivers K times as much current. A unit PMOS transistor has greater resistance in the range of 2R to 3R because of its holes having lower mobility. According to the long channel model, current decreases linearly with the channel length, and hence resistance is found to be proportional to the channel length. Gate and diffusion capacitance. Each transistor has gate and diffusion capacitance, where C is the gate capacitance of a unit transistor, and a transistor of K times unit width will be having a scaled capacitance value as Kc. Diffusion capacitance depends on the size of the source and the drain regions of the transistor. Wider transistors have proportionally greater diffusion capacitance. Increasing the channel width increases the gate capacitance proportionally. but does not affect the diffusion capacitance. So by increasing the channel width, the gate capacitance is increased, whereas diffusion capacitance is not varied. Equivalent RC circuits. The following diagram shows equivalent RC circuit models for NMOS and PMOS transistors of width K with contactor diffusion on both the source and drain. The PMOS transistor has approximately twice the resistance of an NMOS transistor because holes are observed to have lower mobility than electrons. This diagram represents the equivalent RC circuit model for NMOS and PMOS transistors. Quiz questions on propagation delay. Implement the RC delay model of MOS transistor. Give a diagrammatic representation of RC model of NMOS and PMOS transistors. Thank you.